Welcome to CSEGuru. In this session, we will discuss binary search example using array and function. Already, we have discussed three examples using array and function. Finding the largest of n numbers, linear search and Fibonacci number. Now, we will discuss binary search example using array and function. So, what do you mean by search? We have to enter n elements with the array and one element we have to enter as a key element. The key element will be compared with each and every element in the arrays. And if the element is found in the sense, it will return key element form. If it is not present in the array in the sense, it will print the key element not found in the array. The same logic of linear search, but what is the difference between linear search and binary search in the sense? In linear search, randomly we can enter any number of elements. So there is no restriction. And in binary search, if you are considering, since it divides the array into two halves, in every iteration, it is required to enter the elements in ascending order. That is, binary search will work with the sorted array. Unsorted array in the sense, it will return the wrong answer. Okay. So keep in mind, binary search in the sense, input values, we have to give these sorted elements only. Okay. Remaining things, everything is same like linear search and binary search only. Only the logic it will differ. Okay. So like linear search, we have to pass three parameters. One is the key element, another one is the array, and another one is the n, the number of elements in the array. And this is the function declaration. And inside the main function, the same thing, position we have to enter. And position is the integer data type. Similarly, key, array of 20, I and n. Everything is of integer data type. First, we need to enter n value. Suppose n value, here I have entered 5. We have to enter the n elements using for loop. So, n value, if you have entered 5 in the sense, totally 5 memory locations will be allocated for array. And the starting memory location is 0. Next, a of 1 up to a of n minus 1. So, n value here is 5. So, 5 minus 1 in the sense up to 4. So, any elements we can able to give, but the condition here is sorted elements. Okay. So, here simply I will give 10, 12, 15, 20, 25. Okay. So, this is of elements in ascending order. So, only ascending order in the sense the binary search will work properly. Otherwise, it will return wrong answer. Next, key element we have to enter. Suppose if the key element here I have entered is 20. Next, the user-defined function is called. Binary search with 3 parameters. Key element is 20. A is nothing but the complete array. Okay, here we are passing the whole array. So, it is enough to mention only the array name in function call. Only in function declaration and in function header only we have to specify the array with empty square bracket. Not required to specify size anywhere. In function declaration or function call or function header, it is not required to specify the size. And the n, if you are considering in the sense, the value is 5. Here also the same logic as like linear search. If the position value is minus 1 in the sense, it will print key element not found in the array. If the position value was any other value other than minus value, 0, 1, 2, 3, any other value in the sense, it will print key element found in the array. Now we will check the logic here. So the array elements are 10, 12, 15, 20 and 25. And the array location is from a of 0 to a of 4. So, and the parameters here we have passed is key element is 20 and a is the complete array. Okay. N is nothing but 5. Here we have declared 3 variables is of integer data type. Low, mid and high. Okay. So, now low value is initialized to 0. High value is n minus 1. So, n value is 5. 5 minus 1 in this sense, high is 4. Okay. So, now we will take the array 10, 12, 15, 20 and 25. So, the main logic of binary search present with this while loop only. Okay. So, check the condition while low less than or equal to high. So low value is 0, less than or equal to high value is 4. Yes, condition true. Then find the mid position. Mid is equal to low plus high by 2. So low value is 0 plus 4 by 2. So we will get it as 2. So mid location is 2. So A of 2 position is mid location. Okay, so 0, 1, 2. So A of 2 location is nothing but mid. Okay, then compare whether the key element is equal to mid element. So key element is 20. 20 is equal to A of mid. A of mid is 15. So 20 is equal to 15. Condition fails. Okay. Then it will go to the next if statement. Check whether key element is less than A of mid. That is 20 less than 15. Condition fails. It will go to next if statement. And here it will check key element greater than A of mid. So key element 20 greater than A of mid is 15. Yes, this condition is true now. Okay, now low is equal to mid plus 1. Okay, so this is low and this is high. Okay, previously. Now this if statement condition is true. Key element is greater than the mid element. Okay, so now low is equal to mid plus 1. Mid is 2. A of 2 position is mid. So 2 plus 1 is nothing but 3. So now after executing this first iteration of while loop, low is changed to 3 position, A of 3 position. Now, what is the logic here in the sense? In binary search, it will find the mid element and the key element will be compared with the mid element. If the key element is lesser than the mid element in the sense, the search will happen only with the left part of the array. Okay. Suppose if the key element is greater than the mid element in the sense, the search will happen at the right part of the array. Because in linear search, what's the disadvantage we have discussed? If the key element is present as the last element of the array in the sense, the program has to check each and every element in the array. Only at the last comparison, it will found the key element. Okay, so all these comparisons is required. Suppose if the array consists of 100 elements in the sense, only at the 100th comparison, we will find the key element. All these 99 comparison is totally wasted only. Only the 100th comparison, we have find the key element, right? Suppose if the array consists of 1000 element or 1 lakh element in the sense, what it will happen? It has to compare all the array elements. Only at the last comparison, it will found the key element. That is the main drawback in the linear search. To overcome this linear search disadvantage, in binary search, what we are doing in the sense, the key element will always compare with the mid element. If the key element is lesser than the mid element in the sense, the search will happen only in the left part of the array. Suppose if the key element is greater than the mid element in the sense, the search will happen only at the right part of the array. So, every iteration, it will divide the array into 2 halves and the search will happen only at 1 half. If it is the lowest element than the mid element, search will happen at the left part of the array. If the key element is greater than the mid element in the sense, search will happen at the right part of the array. So this procedure will happen for every iteration. So it is not required to compare all the elements in the array. Okay, only half of the element will be compared and it will find whether the key element is present in the array or not. The logic works well here. Okay, and the time efficiency is highly improved. But only one restriction in binary searches, array should be sorted away. Okay, so now we will come to our example. The first iteration of while loop is over. Next, the second iteration of while loop, only these two elements will be compared. So only we will take the right part of the array. It is not required to take the left part of the array as well as the mid element. Okay, so in this right part of the array, now low is nothing but the 20. So here itself we will compare. Low is nothing but 20 and high is nothing but 25. Okay, check the condition whether low less than or equal to high. Low is A of 3 location. Okay, so this is A of 3 location. This is A of 4 location. Low is 3. Check the condition whether 3 less than or equal to 4. Condition true. Now find the mid value. Mid is equal to low plus high by 2. Low is 3. 3 plus 4 by 2. We will get 3.5. So 3.5 in the sense after the decimal point, it won't consider the value. It will consider 3 only. So now the mid element is nothing but 20. That is A of 3 location. Since it is 3. Next, check the if statement. If key equal to A of mid. Key is 20 equal to A of mid in this iteration is 20. Yes, condition is true. And it will return the mid value. So mid is nothing but 3. So now this 3 will be returned to the main function. And if the position value is any other value other than -1 in the sense, it will print the key element is found in the array. Okay. Suppose if the key element is 25 in the sense, what it will happen? This is the mid value. This condition fails. Key element is 25 in the sense, this condition fails. Okay. Check. If the key element is less than A of mid, key element is 25, less than A of mid is 20. Okay. Condition fails. Next, it will check with the next if statement. If the key element is greater than A of mid. Yes, 25 is greater than 20. Now, suppose if we have considered key element 25 in the sense. Now, low is equal to mid plus 1. So, mid is this one. Mid plus 1 in the sense, it will go to next element. Now, only one element is present in the array. Low is also same element. High is also same element. Okay. So, it won't check the left part of the array. It will check only the right part of the array. So, now this mid element also will neglect. In the next iteration, low is same, high is same. If you are finding the mid element, this is the mid element. Automatically, if you are comparing with the mid element in the sense, we will found the search key and it will return the mid element. Okay. So, likewise only the procedure continues. So, if you are entering the key element in the sense, in binary search, the array will be divided into 3. Okay. So, starting array location will be considered as low and the last element will be considered as high. Next, we have to find the mid element. Only comparison will happen at the mid element. If the comparison fails in the sense, it will check whether the key element is lesser than the mid element or greater than the mid element. If the key element is lesser than the mid element in the sense, search will happen only at the left part of the array. If the key element is greater than the mid element in the sense, search will happen at the right part of the array. So, in every iteration of this while loop, this procedure continues until it finds the key element. So, this is the logic of binary search example using array and function. And here also, if you are considering in the sense, we are passing the whole array, not individual array elements. The complete array we are getting from the main function to the user-defined function and we are implementing the logic and user-defined function. Finally, we are returning the result to the main function. Okay. Thank you for watching this video.